Okay, so we are going to continue with the same domain concept, and we will see some more functions. For them, we have to find the domain of it, and then we will move to the concept of range and how do we find a range. Okay. So
Okay.
so in this, okay, let me just put a question. The question is, okay, suppose I have a question. Fx is equal to, let me change the color of it. Fx is equal to log base 10 of log base 10 1 plus x to the 3. Okay, now how do we find the domain of it? So as we have discussed this thing that
Sir, for
okay,
this base there should be a number here, no sir?
no, it is like this. It's log of, what is the basic idea? The basic idea is this: if I have any thing like this, if the base a here, so this is defined only if x is greater than 0, correct? Isn't it? So this x is always greater than 0. So for this, what we should write? We should write that this entire this thing, that means the log base 10 1 plus x cube is defined if what? 1 plus x cube is greater than 0, correct?
Yes sir, so 1 goes there.
So 1 plus x cube is greater than 0. But before that, this log is also defined for something. This is greater than 0, it's okay. But what about this log? See, what about this log? So for this one, what we should write? That log base 10
It's defined defined as
defined it?
alphabetics.
Yes. So it's defined only if this log, okay, you're writing please.
So you write it, so I'm writing, it's not happening.
Let me write first. So this is what? X cube should be, should be greater than 0, correct?
Yes sir.
Okay, now this is greater than 0, it means it can be written as 1 plus x cube should be greater than 10 to the 0. This 10, you should remember, this base 10 can take this number at its power. So now this will become x cube is greater than 1 minus 1, because this is 1, and so x cube is greater than 0, correct?
Yes sir.
And here it says that x cube is greater than negative 1. So if x cube is greater than negative 1, it means x should be greater than negative 1. So from this and from this, what we are getting? We are getting that x is always greater than 0. And so this is our domain. So we can write x belongs to 0 to infinity. Understood?
Yes sir.
Okay. Alright. Okay, so we have to find the domain of function, and the function is, let's say, log 2 x plus 3 divided by x squared plus 3x plus 2. How do we find the domain of this function?
Why is it not writing, sir?
Okay, so x plus 3 should be what? Greater than 0, correct?
Greater than 0. I'm writing that, sir. It's not writing, sir.
Therefore, x is greater than minus 3. And for this entire function to be defined, that is in rational form, the denominator shouldn't be 0. So if we also write that x squared plus 3x plus 2
is not equal to 0, no, sir?
Yes. So x squared plus 3x plus 2 not equal to 0. So is your stylus chargeable? I mean, so please try to write. What are the factors?
Factors, sir. They are like
okay, let me just write x plus 2 and x plus 1 cannot be equal to 0, and so x cannot be equal to minus 2 or x cannot be equal to minus 1, and it is saying that x is greater than minus 3. So it simply means that you have to have all the numbers which is greater than minus 3, but this minus 2 and minus 1 shouldn't be there. So, or not like this. It's not like this. It is x is greater than minus 3. So write x greater than minus 3. So minus 3 to infinity, but only two numbers we have to exclude from there. That is minus 2 or minus 1 and minus 2. Okay.
sir, but if it is greater than minus 3 means it will be like from minus 2 to infinity, no, sir?
But it can be negative 2.5, negative 2.6. This is minus 3 here. This is minus 2 here. This is minus 1 here. So this is saying it is greater than minus 2, but these two numbers should not be there.
Okay.
So this number is permissible, correct? Understood? Okay.
Yes, sir.
Okay. Now let's understand how do we find the range. So remember two things. First, the very first step is first find the domain of the function. And it is what if domain of the given function, and domain is when we have to find, sometimes the domain is itself given there, like when you define any function, so it is given that function is defined for x is such and such. So in that case we don't have to find the domain, but if it is simply given that this is a function, you have to find the range. So first of all we need to find the domain of that function according to its kind or its exact way to find the domain. Now if we have the domain, then we have to see how the domain we have found. If domain is some set of distinct elements, then range will be the set of function values at that distinct elements. I'll explain what does it mean. Means suppose I have a domain, and domain is a set of distinct elements, means like 1, 2, 3, 4, 5, 6 and 7 like this are given, and we have a function already defined. So we have to simply plug all those distinct values in the function one by one, and whatever the output will appear, we have to collect all them in a simple set, and that will be the range of that function. Okay?
Okay, sir.
If the domain is not a set of distinct element, then what we can do? So if domain is just the real number, or real number minus some points, let me just write like this, or subset of real number. And it is not exactly the distinct elements, then what we have to do? Oh, please let me write. Actually, you will write somewhere else. Subset of real. Then if the domain is, please try to understand what I'm teaching, then you will just do the experiments how to write and all. If I just give you the chance to write on the board, please then do it. Please understand what I'm saying. Here domain, if the domain is a real number or the subset of real number, then what we have to do? First of all, we have to express x in terms of y. So if we express x in terms of y, then we have to find the conditions on y with the help of conditions on x. So this is the overall summary and the strategy, or the, you can say, the methods to find the domain. Okay, find the range of a given function. So let's just understand one by one. Suppose I have any function fx is equal to 3x plus 2. It is given that x is greater than or equal to 0, and I simply ask you find range. Then what will you do? Here you have to first recognize or just observe that whether the domain is given or not. So is there any domain given to the function? Hello? Hello?
Yes.
Are you there?
Yes, sir, it's given.
So yes, given.
Yes, sir, I'm there.
Yes. So what is the domain given?
Hello.
Yes. What's the domain given here? Can you please write?
3x plus 2.
No, it's not domain I'm saying. It is actually what? This is a 3x plus 2 is not domain. What is the domain given? This is 3x plus 2 is the definition of function. Domains are just the condition on x. So this is domain given to you, correct? Okay. So
Yes.
So here what
Yes, sir.
I said, that first of all we have to find the domain, and you can realize that domain is not the set of distinct elements. It is the entire range of the values starting from 0, and it will end up to infinity. It means that x is greater than 0. So first of all, what we have to do? We have to express x in terms of y. Find the range by putting all the values of distinct elements and collecting all this output. So if the domain is not in that way, how do you just put the distinct elements like 1, 2 and 3? It can't be that. Okay, so there is a different way. Different way is that what if domain is real number or subset of real number. So isn't it x greater than 0 is subset of all real number? It is always taking positive numbers, correct? So for this, what we have to do, we have to express x in terms of y. So how do we express x in terms of y? First of all, and please just follow how I'm just explaining this thing. So here, first of all, we have to let y is equal to 3x plus 2. Okay. So it is y is equal to 3x plus 2. So for this, we have to express x in terms of y. So we can write y minus 2 is equal to 3x. And so x is equal to y minus 2 by 3. Now, since it is given that x greater than 0, so we will start writing that since x is greater than equal to 0, it means the expression which is exactly equal to x can be just substituted there. It means that y minus 2 by 3 should also be greater than 0, correct? Hello?
Yes, sir. Hello? Hello, yes, sir.
Yes. So this is y minus 2 by 3 greater than 0. So here we write y minus 2 is greater than 0. And so y is greater than equal to 2. And this is the range, basically, because we have found the conditions on y. If you just follow this thing, find the conditions on y with the help of conditions on x. So we had the condition on x here, we had the condition on x, which is x greater than 0, and with the help of which we are here just found that y greater than equal to 2, which is condition on y. And so the range is just y greater than equal to 2, or if you want to write in more formal way, you should write the range belongs to 2 to infinity. Got it? Understood?
Yes, sir.
Okay.
Yes, sir. Just
Okay.
let me go through one second. Second, go back.
All right. Why this is this 3x? Put that button off.
Yes, sir.
Understood? Okay.
Yes, sir.
So here I am giving you. This is y less than negative 2 is the correct one. Good. But yeah, so you write what? Range belongs to negative infinity to negative 2.
Is equal to minus. Oh, is it like that? Sorry.
Yeah, because this is actually less than negative 2.
If it was plus.
Then only then also you write negative infinity.
If it was more than negative 2, sir.
Then you have to write negative 2 to infinity. Correct? Because it's more than negative 2. So you are actually going higher and higher.
Yes, sir.
Isn't it? Okay. Now, there's other way to just do this kind of questions. Let me just put it. Suppose I have any function fx and this is given, let's say 3x minus 1 by 4, and x is less than 0. We have to find range. And this time I'm using a different strategy to solve it. And please try to understand. This is another way to do this. So please try to understand this first, and then you'll try. So another way is what? It is given that we are starting from x. Please understand. In this strategy,
sir, 1 minute, 1 minute. Sir.
With me, what I'm saying in that particular
Yes.
Okay, so in this method, we have simply actually written that y is equal to fx and expressed x in terms of y first, and then impose the same inequality for which x is supposed to be. But here we will actually start writing from the beginning that x less than 0, and we will construct this function slowly. Why? Let's see. I mean how? Let's see. This is what x less than 0, and here you notice that this function is structured in a way that it is multiplied by 3 to x first. So again we will multiply 3 to it. So you can easily realize if a number is less than 0 and if you multiply 3 into it, that will also it will remain less than 0, correct? So there is no such loss of
Yes, sir.
generality. It will be same, correct? Now if we subtract 1, that will be -1 here, and if you divide by 4, that will be -1 by 4, correct? And so now you notice that this is the exactly y what we are looking for. So y will be less than -1 by 4, and so this is our range. Now you try by your method, which we have just discussed on the previous question. Please try that the first method here, and please notice that that will give you the same answer. So you are getting same answer, correct?
Yes, sir.
All right. Okay, so if you remember, we have discussed a function which is called greatest integer function, correct? Okay, so before that question, let me just give you this one. What about this kind of questions we have discussed before, that fx is equal to square root of x square minus 9, and we have to find the range. So remember, whenever you are simply asked to find range and it is not the domain is not given, it means we have to first find domain, correct? Hello?
Yes, sir. Hello.
Yeah, so please find this domain first. How do we find the domain?
Positive, negative, those things.
This is positive, this is negative, then this is again positive. So x should be greater than 3 and x should be less than -3. Okay, so domain what we get is just x belongs to negative infinity to negative 3 and union 3 to infinity. So that's the domain we got, and this is our previous actually knowledge that domain is this one. Now the main thing is, how do we find the range of this? And this you can simply understand that this is the condition which is very integrate form, the very complex form. And how do we use this condition of x to find the condition in y for this function? So it's very straightforward. We have to just find range. So we'll write let y is equal to square root of x square minus 9. And now this time we are not going to extract x from here and express x in terms of y, because that will actually give you in trouble. Not in trouble, but this will be a lengthy process. So we will use this technique. We have learned just this another way. We will start from x. So as you see that x is lying beyond 3 and x is lying before negative 3. So for any x belongs to this number, I mean this interval, negative infinity to negative 3, union 3 to infinity, you can see that x squared will always be greater than 9, correct?
Yes.
Why? Because this was the exact result from here. You see? This was the consequence of this inequality. So if I am just writing this inequality, it means you have to write x square minus 9 greater than 0. So x square minus 9 is always greater than x square is greater than or equal to 9 for any x which is lying between this interval. Okay, so what we do now, we can simply see that, oh, this x square is greater than 9. It means x square minus 9 is always greater than 0, and once we do the square root of it, it will become x square minus 9 is greater than or equal to 0, and so this is nothing but the function y. So y is greater than or equal to 0, and then the condition on y we have found with the help of the condition on x starting from there. Okay, so this is our range, and this is 0 to infinity. Got it?
Yes.
Okay.
1 minute.
So please find this one. Sorry. Nothing to do. So negative 2 to 2.
Excess minus less. How's the negative 2?
Because 2 plus x is
Both
0.
are positive.
This is 2 minus x. You will just,
okay.
if you equate 2 minus x with 0, so 2 minus x is 0, then x is equal to 2.
It will give minus 2. Okay.
So that will give you positive quantity, that will give you negative, and that will give you negative. Okay. So the domain is just negative 2 to 2. Is 3 less than 5? If I multiply,
minus 3 will be more than minus 5.
It means this inequality
Sir, minus 3 will be more than minus 5.
So I am saying the same thing. Now, if I multiply negative sign, it will be reverse. So here also the same thing is applied, that x square is lying between 0 and 4. So if I multiply negative sign, this sign will get switches. This 4 will come here with a negative sign, 0 will go there, correct? But here after we have this 4
Yes,
added
sir.
to it. So if I add 4, you will get this thing 0. This will be 4 minus x squared and this will be 4, correct?
Yes.
Because you are adding
Yes.
4. Okay. So now you have to take the square root of it. So if you take the square root of this 0 and take the square root of this and take the square root of this, that is 2, and this is the same function we are looking for, that is y. So it is y is lying between 0 and 2. That is the range of the function. Okay.
Okay.
Let's do fx is equal to is
Not
greater than
infinity,
is
sir.
greater than 3.
Sorry.
It's greater than 3. That's why.
Yes.
This is what here. X is always greater than 3. And this is actually this bracket, square bracket, because 3 is enclosed. Actually, means 3 is enclosed. So x is greater than 3. It means that
And
we have to subtract 3 from here because x has condition. So if we subtract, that means x minus 3 is always greater than 0, and once you do the square root of it, that will become square root of x minus 3 is always greater than 0, and so y is greater than 0. So that is the range. Okay. Understood? You are simply
understood, sir.
Yeah, constructing from whatever you have already for the domain. Okay. Fx is given that x squared plus 1 plus x squared, and here the domain is given that x belongs to a real number. We have to find range.
This time should we follow the last method, sir?
Which method?
Get it?
Yeah, x is every real number, and we have to find the range. So actually, okay, let me just okay. So I will just guide you that first let this as a y, and try to extract or try to express.
Yes, sir. That's what I asked, sir.
Okay, try to write x in terms of y,
In
please.
terms of x.
X in terms of y.
1 second.
X as a subject of y you have to write.
Is it like this? No.
I said in order to find range, because the domain is already given, you have to write x in terms of y first. So first of all, you have to assume or just let that y is equal to x squared by 1 plus x squared. Now how do you write x in terms of y, as we did in the previous questions? Can we just write x in terms of y? Please do it. So here x is already there. This x is not alone. Let me just teach you how to find it. So please just follow. It's the first time, so it will be good to just watch. See what you do. You write y times 1 plus x squared on the left hand side, and this is x squared. Now this is y plus yx squared is equal to x squared. So keep all those terms containing x on one side. So just leave this y on this, leave this y on the left hand side, and take this yx squared on the right hand side to just write like this. Now from the x squared, from this two terms on the right hand side, we can take x squared as a common. So if I take this x squared as a common, I can write it 1 minus y, correct? And then y by 1 minus y is equal to x squared, and so now x is 1 over this thing, I mean y over 1 minus y the square root. So you can see that y is just one side and x is just alone on the left hand side or right hand side, whatever. Now from here, how do we find this? How do we find that range actually? So we see that what we have.
So y mine root over y.
X belongs to R. It means x is real, and so this square root is defined only if y over 1 minus y is greater than equal to 0, correct? Because any square root will be defined only if the inside expression is always positive. Is a basic rule. So y over 1 minus y is also going to be positive if this square root is defined, correct? So what you write from here, since y over 1 minus y is greater than 0, so we need that this ratio y or 1 and 1 minus y should be positive. So again we have two roots, one for numerator and one for denominator. As we do for some two factors multiplied, we can also do for the two factors in ratio. So the two roots y is for 0 and that is for 1. So any number lying between 0 and 1 will give you this thing always positive, correct? This is negative and that is negative. We don't need negative. It means the y should lie between 0 and 1. But remember, 1 cannot be taken in this interval. 1 cannot be inclusive, because if I substitute 1 here, I will get this expression not defined, because in denominator we cannot put 1, correct? And so range is just 0 to 1. Alright. There is one other way to just find this range of the same function. We have y is equal to x squared over 1 plus x squared. And please just actually understand this carefully. This is very important. As given that x belongs to R. So you notice that this denominator and numerator is composed of x squared. So for any x, the denominator cannot be 0 because it's always positive. Now you see that for x belongs to R, means for any real number, x squared is always positive, correct? Or not?
Yes.
So when I divide, so when I divide this whole expression, this x square with 1 plus x squared, it is always giving you greater than 0, and so y is always positive. This is the first thing. But also notice that for any x belongs to R, this x squared is always less than 1 plus x squared.
Yes.
because x square is 1 less than 1 plus x square. It means the denominator is always more than the numerator. In other words, if I just divide this entire inequality with 1 plus x square, I can write it as x square over 1 plus x square is less than 1. And this is exactly y. It means y is less than 1. So combining this first and 2, what we can write? From 1 and 2, we can write that y is lying between 0 and 1. And that is exactly what we got in this method. So actually you can now understand that in order to find range, it's not necessary to follow one rule. It is our actually intuition and also some good experience based on practice, which can simply lead to your perfect way to deal with the question. Okay. So you have to do a lot of practice on this domain and range questions. I will actually post some, I have also posted some of the assignments in the Google Classroom. And if you're not following, it's not my fault. Okay? And also, if you are doing RD Sharma, then that's okay. But only way I can see whether you are following and doing some homework or not, that you can just do the questions in Google Classroom. Okay?
Google Classroom, you have
plenty of assignments in every chapter and every lesson. There are assignment. There's a video. So this is the same video what I teach you. So you can just refer if you just feel any trouble. Also, the Google the classroom note is also there, so that you can just follow whatever I have you have to actually studied in the class.
I do see the notes, sir, but I do not do assignments.
So there is always quick quizzes.
Quizzes also I have done, sir.
How many quizzes we have done?